Hi guys, welcome back to Chemistry 24 into 7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem. So this is the continuation of our Suzuki cross-coupling reaction series. So this is the question from CSIR 2017. As per this question, this terminal alkyne react with catechol borane and followed by water that produce intermediate A. This intermediate A react with this alkynyl bromide in the presence of palladium catalysis under potassium hydroxide that produce product B. So here you can see that four options are given. Let's solve together which one is the correct option for this question. So first write down our question. The first step of the reaction is terminal alkyne react with catechol borane. So this reaction is hydroboration reaction. So according to hydroboration reaction, terminal alkyne react with this catechol borane by syn addition. So syn addition means that this hydrogen atom and this boron part going to order same phase of the alkyne. So in particular, this reaction follows the anti-Markovnikov rule. So according to anti-Markovnikov rule, hydrogen atom going to add this carbon. In case of this boron part going to add terminal carbon. So resulting that produce this corresponding boronate species. This boronate intermediate which then react with water. So here hydrolysis takes place to produce this boronic acid which is alkynyl boronic acid and catechol. So this alkynyl boronic acid is our intermediate A. So this intermediate A which then react with alkynyl bromide and palladium catalysis and potassium hydroxide. So this is the condition of Suzuki cross-coupling reaction. So we have already discussed about Suzuki cross-coupling reaction in our channel there catalytic cycle and mechanism and various problems. So let's moving to the our second part of the reaction. So initially this reaction requires a palladium 0 as a active catalysis. Therefore palladium 0 active catalysis would be a first step of the reaction. So after the generation of palladium 0 active catalysis, which then undergo oxidative addition with this alkynyl bromide. So which produce this corresponding intermediate which then undergo metathesis reaction with potassium hydroxide. So here you can see that here bromo atom replaced with hydroxide ion which produce this corresponding palladium complex along with potassium bromide byproduct. At the same time, boronic acid species react with potassium hydroxide. You just remember that this reaction requires the base, so which is essential to activate the boronic acid species in order to undergo transmetallation reaction. So here you see this potassium hydroxide now react with boronic acid which produce this corresponding species. So now this species is ready for transmetallation. So now this palladium complex and this species undergo transmetallation which kick off this corresponding byproduct and produce this corresponding palladium complex. So this palladium complex next step undergo reductive elimination to produce this corresponding carbon-carbon coupling product along with the generation of palladium zero active catalysis. So here we should note that the stereochemistry of alkyne geometry. So first you take this alkynyl bromide geometry. So here you see this bromo atom and methyl group both are present at cis to each other, which means that so this is the coupling side. So incoming group going to couple this position. So definitely that incoming group and this methyl group should be present at cis to each other. So let's examine our product structure. So here you see this methyl group. So this is the incoming coupling partner. Now these both groups are present cis to each other. So next we should see the geometry of this boronic acid, alkynyl boronic acid species. So here you can see that this N-butyl group and this boron part both are present at trans to each other, which means that this is the coupling side. So that incoming group should couple with this part by trans to each other. So now you see our product structure, this N-butyl group. So this is the incoming coupling partner. So both are now present at trans to each other. So let's moving to the our question. So as per our discussion, among the four answers, the correct option for this question is option 2. That's it for today's problem. I hope this video has helped you to understand this Suzuki cross-coupling reaction. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe. Come or come for much more content like this. And finally, thanks for watching. Bye bye.